Okay, in section 8.2, we're going to graph y equals x minus h to the second power plus k. So we're going to graph parabolas, but we're going to use horizontal and vertical translations to graph them. Okay, before we graph them with their translations, we're going to graph the parent functions. Parent functions just tell you kind of what general shape each type of graph makes. So we're going to graph y equals x to the second here, which we did last class. I'm going to make a table, but after this, you will not need to make a table for this. Okay, normally when I give you a table, I give you 2, 1, 0, -1, and -2. Okay, if I plug in x, 2 to the second power is 4, 1 to the second power is 1, 0 to the second power is 0, -1 to the second power is -1 times -1, which gives me +1, and -2 to the second power is +4. So let me graph those points: 2, 4, 1, 1, 0, 0, -1, 1, and -2, 4. And I'm actually going to label those because some of you don't have graph paper, but also because they're important points, because every parabola will start out with this fundamental shape. I'm going to go ahead and sketch my parabola. It should be U-shaped. It does open up. We can see the vertex is at 0, 0. Okay, this is the general shape for a y equals x squared graph. Okay, I'm going to go ahead and graph y equals -x squared. And I will make a table, but after this, I will not make a table. I will just know the shape it's going to make. Okay, let's see, I could use the same points for x. Okay, if I do 2 squared, I get 4, and when I apply the negative, I get -4. 1 squared is 1, multiply by negative, I get -1. 0 squared is 0. -1 squared is +1, but when I multiply it by a negative, I get -1. -2 squared is +4. When I multiply it by a negative, I get -4. So I'm going to graph these points, and then I'm going to label them because this will provide our parent function for y equals -x to the second power. Okay, I labeled the points. You can see my parabola. It also has a vertex at 0, 0, just like y equals x squared. This parabola opens down, and whenever there is a negative in front of the x squared term, the parabola will always open down. And it will always make this same shape of points. Starts with vertex 0, 0, 1, 1, 2, 4, and then on the left side, -1, 1, -2, 4. And when it's negative, it does the same except for it's going down. Side 1, down 1, side 2, down 4, side 1, down 1, side 2, down 4. We're going to keep that shape in mind because that is going to be the general shape for all of our graphs today. Okay, so now we're going to graph y equals x minus h squared plus k, or I could change the signs around. Okay, so when I graph something like this, I start out with this shape. And then depending what's in the parentheses or at the end, it's going to move the vertex or the graph. So when it's x minus h, this moves the graph or the vertex right h units. And then the plus k will move it up k units. And we'll graph some in a second so you can see what that means. Okay, now the parentheses always does left or right. If it's x minus h, it went right h units. If it's plus h, it actually goes left h units. Okay, and on the previous equation, when there was a plus k at the end, it went up k units. When there's a minus k, it does the opposite. It goes down k units. And we could mix and match this scenarios depending on the graph we're going to graph. Okay, so we're going to go ahead and graph these functions. Okay, for each graph, I'm going to describe the translation, which will mean that the vertex is going to go right something units or up something units. And then I'm going to graph using the shape from above. So first, let's look at the translation. Okay, because this is a squared, it's going to make a parabola. If I look in the parentheses, it says x minus 2, which is similar to this. So this is going to go right. And in this case, it has a 2, so it's going to go right 2 units. I'll just say right 2. At the end, it has a plus 3. Plus makes it go up. So we're going to move the vertex up 3. Okay, now I'm going to move my vertex. Normally the vertex is at 0, 0. But because of the translation, I'm going to go right 2, 1, 2, up 3, 1, 2, 3. And I'm going to put a new vertex there. And And I didn't do any work, I just know that's where it's going to move to. Okay, now because it's squared, I know it's going to do a parabola. So it's going to make the same pattern from the vertex as the previous parent functions. So normally we go 1, 1, 2, 4. So from the vertex, I'm going to go side 1, up 1, and make a dot. And then from the vertex, I'm going to go side 2, up 4. And then I'm going to do the same thing on the other side. So on the left 1, up 1, left 2, up 4. And it should look symmetric. This point matches this point matches this point. And then I draw the parabola, and it makes the same shape as y equals x squared, except for the entire graph shifted right 2 and up 3. So let's try the next one. Okay, first I look in the parentheses. Since it's x plus 2 in the parentheses, that's like this one. This means left. So this is going to go left 2 units. Let me look at the end because there's a number at the end. At the end it says -1. If there's a minus at the end, that represents going down. So I'm going to move the vertex first. Normally the vertex is at 0, 0. Now the vertex is going to move left 2, down 1, and I'm going to redraw a new vertex there. Okay, from there I'm going to draw the shape of the parent function for x squared because this is quadratic. So from the vertex, I will go right 1, up 1. And then from the vertex, I will go right 2, up 4. 1, 2, 3, 4. That's because of 1 squared and 2 squared. On the left side of the vertex, I do the same thing. -1, up 1. -2, up 4. Okay, and they kind of match. Some people just match it over. Okay, that's the shape. And I moved it left 2, down 1, but it makes the exact same shape as it did previously. Let's go ahead and move to C. Okay, there is a negative in front on this one, which tells me it's going to open in the downward direction like the second parent function, but it doesn't affect the way the vertex is going to move. So let me look at that first. So in parentheses, I have x -1, which means it will go right 1. At the end, I have a +4. The number by itself means up or down. In this case, it's going to go up 4. So I'm going to go ahead and start. My vertex is normally at 0, 0, but I'm going to move it right 1, up 4. Okay, now from there, I want to draw a picture of my parent function. It's going to be the same as the normal parabola, except it's going to open down. So it's going to be like this guy here because it's negative. It still goes 1, 1, still goes 2, 4, except for it's going to go down instead of up. Okay, so from the vertex, I'm going to go right 1, but this time I'm going to go down 1. And from the vertex again, I'm going to go right 2, down 4. 1, 2, 3, 4. And then I'm going to match it on the left side. So on the left side of the vertex, I go left 1, down 1. Left 2, down 4. Put it over here. And it should look even. If it looks a little crooked, you're going to check your points. And it did open down, but it is still a parabola. And remember, it was this negative sign in the front that caused this parabola to open in the downward direction. Okay, let's try a few more. Okay, let's look at D. It is quadratic, it has the squared, but I can see there's a negative in the front. The negative is going to make it open down. It's not going to affect anything other than the way it opens. Okay, let me look in the parentheses. Parentheses always show you whether the vertex is going to go left or right. Because it's plus, it will go left 2. The number at the end always tells you up or down. So in this case, it's going to go up 4. So let me start. Vertex is normally at 0, 0. I move it left 2, up 4. 1, 2, 3. Okay, because it's going to open down, I'm going to follow the same pattern, but I'm going to open it down. So from the vertex, right 1, down 1. Okay, and then from the vertex, right 2, down 4. Okay, on the left side, I do the same. So from the vertex on the left side, left 1, down 1. On the left side, left 2, down 4. Remember the 1 1 comes from 1 squared. The 2 4 comes from 2 squared. Okay, let me open it in the downward direction. So it opened down and the vertex moved left 2 up 4 from where it normally is. Okay, the last two are the same. It's just one piece of information is missing. Okay, so I see parentheses. So because it's in parentheses, it's either left or right. Because it's a plus 3, it's going to move left 3. Since there's nothing at the end, it's not going to move up or down. It's just going to move left 3. So normally the vertex is at 0, 0. I shall move it left 3. 1, 2, 3. Okay, now this parabola opens in the normal direction, opens up. Okay, so from the vertex, right 1, up 1. Right 2, up 4. Always from the vertex. From the vertex, left 1, up 1. Left 2, up 4. Okay, so it's a parabola. It opens up, but the vertex did move left 3, which made the entire parabola move left 3. Okay, last one. Okay, for F, let's see, I see this negative in the front, which tells me it's going to open down, but it doesn't affect anything other than the direction it opens in. There's no parentheses at all, but it does have this plus 5 at the end, so that's going to move up 5. So normally it's at 0, 0. Let's move it up 5. So now the vertex is up here at 0, 5. It's going to open in the downward direction. So from the vertex, I'll go side 1, down 1. Okay, from the vertex, side 2, down 4. Okay, then the opposite side will match. And some people kind of just look at it and match it up. So this opened in the down direction, like I expected, and the vertex moved up 5 from the origin.